Welcome to question 3 of the 2021 Mathematical Methods Exam 1 for the Northern Hemisphere. In this video, we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. So for question 3, we have Steffi is raising money for her school with a lucky dip game. In the game, 100 identical cubes numbered 1 to 100 are placed in a large container. The container is then thoroughly shaken. A player pays $2 and is blindfolded so they cannot see. The player then selects a cube at random. If the number on the selected cube is a multiple of 10, so numbers like 10, 20, 30, 40, up to 100, the player wins a cash prize of $7. The cube is then returned to the container, which is important to know, and it's thoroughly shaken again. Then the next player makes a random selection, and each selection is independent of previous selections. For part A, it says find the probability that a player will win a cash prize of $7. So to win a cash prize of $7, they need to select one of the cubes that's a multiple of 10. There's 10 cubes that have a multiple of 10 written on them out of a possible 100, which simplifies to 1 over 10, or 0.1. So that's the answer to part A of this question. From the examiner's report, we can see that that is the correct answer. For part B, it asks, what is the expected loss to a player per game? So this is a discrete random variable, so I'm just going to use X to represent the possible outcomes. So the player pays $2, so they can either lose $2, which I'm going to put as -2, or they can win a cash prize of 7, which means they gain $5. And then we also need to consider the probabilities of each of those outcomes. And we just found that the probability of them winning was 1 on 10. So the probability of them losing the $2 is 9 on 10. So to calculate the expected loss, so the expected amount of money that they will lose, that's going to equal the X value times its probability value. So it's going to be -2 times 9 on 10 plus 5 times 1 on 10. So that is going to equal -18 on 10 plus 5 on 10, and that is going to equal -13 on 10. So the player is expected to lose $1.30 each game. So that is the answer to part B of this question. The examiner's report just outlines the same method that we used on the previous slide. Part C says that capital P hat is a random variable that represents the proportion of games won by a player in a random sample of 3 games played. We want to find the probability that P hat is equal to 2 divided by 3, or in other words, that they win 2 out of 3 games. So to set up this question, I'm going to let capital XN, just so it's a little bit different to what I was writing on the previous page, be the number of games won. Therefore, Xn is distributed binomially because it's independent of any previous selection. So that was told to us up here. The number of trials is the 3 games that were played, and the probability of winning was still the 1 on 10 that we found in part A. Therefore, if we want to calculate the probability that capital P hat is equal to 2 on 3, that's the same as calculating the probability that Xn is equal to 2. So therefore, the probability that capital P hat is equal to 2 on 3 is equal to, and what we want to do is we want to take 3 games and choose 2 of those to be a win. We want the probability of a win being raised to the power of 2, and then we need the probability of failure, which will be 9 on 10, to be raised to the power of 1. So now 3 choose 2, there's 3 ways that that can happen. So this will become 3 times 1 over 100, so that's 1 over 10 squared, times 9 over 10 to the power of 1. So multiplying that out, the top line will be 3 times 1 times 9, which is 27, and the bottom line will be 100 times 10, which is 1000. So the probability that we were asked to find in this question will be 27 on 1000. From the examiner's report, we can see that they got the same answer as we did.